School. I'm your science teacher. We are learning chapter 11, The Human and the Colorful World, right? The chapter sounds to be very interesting day by day. Now, the last time we have seen how does the stars twinkle. Let me reframe a little more on it quickly. And then we are going to see today the advanced sunrise and the delay sunset and the Tyndall effect. They both depend upon light and its refraction kind of thing. Let us see quickly. So, again, right, as what I said yesterday, twinkling of the stars. The twinkling of the stars is due to atmospheric refraction of starlight. Okay, so as you know, the stars are very far from us. The star can produce its own light, so it does not depend upon sun. So star, when the light comes from the star, it reaches us. So let me show you it again, right? See, so let's say, let me draw for you. So let's say this is our earth. Okay, this is our earth, and we call this as our atmosphere. Okay, so let's say we call this as our atmosphere. Now let me draw it a little more bigger. Okay, fine. So this is your earth. Okay, and this is your atmosphere, right? So this is our atmosphere. Okay, so it goes everywhere. Now let's say there's a star here. Now when a light comes from the star, it usually comes straight. Okay, so the light comes straight like this. Fine. So a light is coming from the star. Now, as you know, here it's all vacuum here, right? Here it is vacuum. So there is no refraction. But when the light enters the atmosphere, at that point, what happens is, when the light enters the atmosphere, the medium changes from vacuum to air. From vacuum to air. So when a light enters, let's say there's a person here. Okay, when a light enters, okay, when a light enters, what happens is the light get bent, right? Definitely, it is moving from rare medium to dense medium, so it bent towards the normal. So it bent towards the normal, and uh, this is how the light reaches to us. But you know, our brain interpret it straight. Okay, so our brain normally interpret it straight, right? So the star which is looking at this place, we can see the same star at here. So this is, as what I said, this is the actual position, and this we call it as a apparent position. Okay, this is apparent position. Understand these two things I'm talking. See, when a light comes from the star, it bends and reaches to us, but our brain interprets it straight, right? This is the reason you can see the same star not at its place, but you can see above it. That is the apparent position. Now, this is not the reason why does the star twinkle. The reason for the star twinkle is, as what I said, as the air flows, the physical changes, right? The change, the this medium, the medium keeps on changing because the hot air goes to the cold air goes to the hot air. Hence, there is a fluctuation here. There's a fluctuation here. Because of that, the star, right? The star will become dark and light, dim and light, dim and light, dim and light because of this light. And this is how you can see the stars twinkle. Okay, because of this apparent position, it keep on changing, and that is the reason the stars twinkle. Okay, see. The starlight, when entering the Earth atmosphere, undergoes refraction continuously before it reaches to the Earth. Right? The atmosphere refraction occurs gradually, changes the refractive index. Since the atmosphere bends straight lights, its the apparent position will be slightly different than the actual position. But as you know, the apparent position is not stationary, it is changing as the atmosphere is not stationary. Okay, means the physical conditions of the atmosphere is not stationary. Because of that, this is very important. The apparent position of the star fluctuates. Of the star fluctuates, and the amount of light entering into eye flickers. Right? So sometimes the stars look brighter, sometimes the stars look faint, and sometimes it looks brighter. And this is how the stars twinkle. Now, let's see the next part of it, advanced sunrise and a delay sunset. Okay, so advanced sunrise. So let me again draw for you. This is our earth. Okay, this is our earth. And let's say this is our sun. Okay, now I draw actually sun a little smaller in size. As you know, we all can see it later. Actually, it is very big in size. So this is our earth, and this is sun. Okay, now let me draw a little thing here. Let's say there's a person standing on the earth. Now, what do you mean by horizon or horizon, right? See, they have written something called horizon here. Now, what is horizon? Horizon is what? We always try to see everything straight, right? So it's like this. When a ray of light, right? When a ray of light comes, when a ray of light comes, our eyes always try to see it straight. So this is called a line of horizon. Above the line of horizon, you cannot see anything. Just a second. Let me take this whole thing down. So above, again I am saying, above horizon you cannot, above horizon you cannot see anything, right? So you cannot see above the horizon. Okay, so here, as what I say, if the sun is below the horizon, you cannot see the sun. Why? Because whenever the rays of light coming from the sun, right, it not reaches to you, it not reaches to your eyes. And as you know, we, if it cannot reaches to your eye, cannot see the sun. But let's say the sun is here, right? Let's say your sun is here. Okay, or let's say a sun is here. So whenever a light comes, right, a sun is here. Whenever a light comes, right, it comes straight to your eyes, and that is how you can see the sun. So always remember, you cannot see anything below the horizon. So this is your horizon, this is your horizon. Okay, you cannot see below the horizon, right? And you can see properly above the horizon. This is all about horizon. But the question is, we are talking about early sunrise and a delay sunset, right? So we have an atmosphere here. We all know that our atmosphere is always there. So this is your atmosphere. Okay, this is your atmosphere. Now what happens is, whenever a light comes from the sun, whenever a light comes from the sun below the horizon, what happens is, it's actually, right, this, the sunlight is coming like this. Okay, so ideally the sunlight should go, okay, ideally the sunlight, if there is no atmosphere, this sunlight, right, this sunlight should ideally go away from you, right, like this. It should go straight like this. Yes, but what happens is, because of atmosphere, this light from the sun, it is not going away, it in fact bend and comes to your eyes. Can you see? Yes, yes. So even though the sun is below the horizon, you can still see the sun. Even though the sun is below the horizon, you can still see the sun because of atmospheric refraction. So what happens is, our eyes, as what I said, will always try to project it straight. Okay, so our eye always try to project the sun which is at the down, the sun which is at the bottom, right, we can see the same sun here, right? So this is your actual sun, and this is this sun is the apparent position. So basically here also, because of atmospheric refraction, the sun which is, even it have not rise so yet, but still you can see that sun. Why? Because of atmospheric refraction. And when we try to find out, how much time does it take from here to here, and that time is nothing but that time is 2 minutes. So how much early your sun rises every day? 2 minutes. And the same thing happen during sunset also. So even though sun has already set, but you can still look your sun above. So 2 minute early sunrise and 2 minute delay sunset. So total you can see the sun how many minutes more in a day? 4 minutes. Understand, very beautiful topic. It's all because of atmospheric refraction. First thing, what did I say? Actual sunrise, right? The sun is below the horizon. So we don't have to see the sun. But what happens is, because of atmospheric refraction, you are trying to see the sun, and our brain interprets it straight. So we can see the sun at above the horizon. Above the horizon. So if you go and straight see, the sun is not there. It's actually below. So how much time does the sun need to take from actual to apparent position? 2 minutes. Okay. So this is what happened, and this is how the atmospheric refraction happened. Okay. Let me show you. See. The sun is visible towards 2 minutes before the actual sunrise and 2 minutes before the actual sunset because of atmospheric refraction. So understand what is the main logic behind it? Atmospheric refraction. Okay. So what do you mean by actual sunrise? The actual sunrise means the sun has to cross up the horizon, then only you can see the sun. And the time difference between the actual sunrise and actual sunset is about 2 minutes, right? So this is what happened, and the all phenomena happen, it is because of atmospheric refraction. Okay, so please put your efforts and understand this thing. So tomorrow we are going to see the scattering of the light, a new topic. On based of scattering, this is the last phenomena of scattering. Scattering helps you understand Tyndall effect. Why does the sky look blue in color? And the last part, you have noticed that the sun during sunrise and sunset should look little different in color, like red or more reddish shade or orange shade, right, rather than yellow or something. So this is other three topic. We are going to see the next one. Okay, so hope you understand what I'm trying to say. I'll see you in the next session. Bye, take care.